All right, so remember when you're writing slope-intercept equations, doesn't matter if it's from a graph. Okay, in this case today we're looking at from information. You gotta have two things. You gotta have slope. You gotta have a slope. You gotta have a y-intercept. If you have those two things, you can fill out those parts of the equation and have the equation of a line. So slope can come from a graph, rise over run. It can come from a table, your delta y, your change of y over change of x. You can also get slope from 2 points. You can either use the stack and then use delta, or use the old slope formula. Okay, now for your y-intercept, if you're given a graph, just see where it crosses the y-axis. Okay, we're not doing from a graph today. We're looking at tables and points. So today you have to look for when x is 0 in a table, the left-hand column, or when x is 0 in a ordered pair, the first value of the ordered pair. All right, first example is actually the most easy, straightforward problem you'll be ever given here. You have to write the equation of a line, because we need two things. You got to have a slope and a y-intercept. In this case, they actually gave us both. Okay, so we're trying to fill out y equals mx plus b. We need to have a slope and a y-intercept, and we're given both here. First thing we read is the slope of 4. So that number 4 will go right there in the equation. So we'll have 4x, so y equals 4x, and then the y value of our y-intercept there, we know it's a y-intercept because they told us it was, and we see x is 0 as well. So that would be a positive 5, so 4x plus 5 for the equation. All right, so in this example, we are not given the slope. Okay, are we given the y-intercept at all? Yeah, we see we have a y-intercept. Is it the first one here, 6, 2? No, it's this one here. We know it's a y-intercept because 0 for x. So we already have half of our equation. We know this is the y-intercept. We're going to have something and then minus 4. All right, so how do we find the slope? If we don't have it, we have to find it either through our formula or through our stack and delta method. So I'm going to do the stack and delta. I'm going to stack the coordinates and see the change of y over change of x. So put 0 there, negative 4 there. So how is it going from 2 down to negative 4? Minus 6. Minus 6. On the number line, count those number of jumps down. So negative 6 on top. And then how's it change from this x value to that x value? 6 to 0. It subtracts 6 again. Okay, so negative 6 over negative 6 equals 1. Positive 1 for the slope. Positive 1. Now, do we have enough information to write the equation? Yes. Yeah, we have the slope and the y-intercept. So we're going to rewrite it. So y equals 1x and then minus 4. There's our y-intercept and there's our slope. Now, we don't typically write the slope as 1x, so the equation in a more simplified, better form would be just x minus 4. All right, so now we're looking at an example where we're not given the slope and we're not given a y-intercept. We know these are not y-intercepts because the x's are not 0. So we can't just find the slope and write the equation. We got to do a little bit more work. Okay, so we still need to find the slope first. So let's do that first. So how are we going to find the slope here? We could stack and find the delta y method once more. All right, so I'm going to put this one underneath. So 3, negative 11. All right, so how do I get from negative 15 to negative 11? Add 4. So my first part of my slope will be 4 on top. And then my change in my y, or x's, is what? Minus 2 in my x's. So 4 over negative 2 would be negative 2. Negative 2. All right, now the harder part is finding the y-intercept here. We're going to do it the harder way, in my opinion, and that's moving through the points with the slope, either moving back or forward to the y-intercept using the slope ratio. All right, so we're going to build a little small table here, a little mock table with those given coordinates. So let me make some room here. So the first coordinate we have is 3, -11. 3, -11. And the other coordinate we have is what? 5, -15. Okay, so you could stack them like you would for finding the slope. You could also think of it like a table here. So if I want to move back up and down the table, I need to get to the x value of 0. So that would be 2, 1, 0 right there. Okay, it's going to be 0 comma something. So if I'm going to move with the slope here, in this direction, we know the slope is -2. So we would be subtracting 2 and adding 1 there. So that next value in between would be 1, -13. If I want to go the other direction, I just do the exact opposites. So instead, let me get a different color. Instead of subtracting 2, I'm going to add 2. What's -11 plus 2? -9. And then instead of adding 1 to the x, I'm going to subtract to go back like that. That value would be 2. You know, I just realized that's supposed to be a 4 right there, by the way. Okay, 3 plus 1 is 4. Okay. Now, are we there yet? We have how many more jumps of the slope here? 1? I think 2 more. So if we do 1 more, we would be adding 2 to get to -7 and subtracting 1 to get to 1. We're not quite there yet, but we subtract 1 more there and we add 2 more there, we would have -5, and there is our y-intercept. Okay, so again, this, in my opinion, is a longer way, and then what I'm about to show you next. But you can do that. It's just like sequences, where you can move back and forward with a common difference. You can do the same thing with linear equations. You can move back and forth the coordinates using the slope. All right, now that we've worked back to our y-intercept and we have our slope from the previous step, now we could write the equation. Let me zoom out just a little bit so I could do that. The final step 3 is write the equation. So we know y is going to be equal to our slope that we saw up here was -2. So -2 times x, and our y-intercept that we saw was -5, 0, -5. So -2x minus 5. All right, for the next example here, we're going to do another method. It's the way that I was actually taught. It's called the solve for b method. So let's go ahead and add that to the side right here. This is the solve for b. That means we're going to be solving for the y-intercept here. Okay? So the very first thing we're going to do, whether we use the work backwards with the slope or this method, we have to find always first the slope. Okay? You got to find the slope first. So you can use your formula or you can stack and find the change. Let's do that one more time. So our slope m, let's go ahead and stack these. -10 underneath and 18. So how do you get from the y value -3 up to the y value of 18? You add 21, a positive 21 of y change on top. How's the x changing the same direction? It's subtracting 14. Subtracting 14. So -14 on the bottom. Simplify that ratio to be -3/2. -3/2. So there's our slope. That's half our equation. Okay. Now we're going to solve for the y-intercept. So step 2, find the y-intercept. All right, so what we're going to do is in our equation, our slope-intercept form, y equals mx plus b. Right now, after step 1, we actually have 3 parts we could fill in here. We have the m, -3/2, goes right there. But do we have an xy given to us anywhere? Yes. Yes, up here we have two of them. This pair of x and y, or this pair of x and y. So we're going to use the smaller ones here and replace x, y, and m in this equation and then solve for b. So again, we replace the x, y, and m. We're going to take the x, y from the smaller pair. We're going to use this pair right there. So that'll be our x value and that'll be our y value. So start replacing those values in slope-intercept form. So the y is -3, so I'm going to write -3, replace that. Still equals, now the m we solved for, we got that one, was -3/2. The x value that goes with this y value is 4, so then go right there for x, that'll be a 4. So times 4. And now we're going to be adding the b, we don't know, and we're going to solve for it. We replace 3 things and solve for the one unknown part. So let's go ahead and simplify. So we'd have -3 equals -3/2 of 4 is -6 on your calculators. And then now we have one step to get rid of the number next to b. What we're going to do? We're going to add 6 to both sides. Add 6 to both sides. That would give us +3 equals b. Or, a better way to look at it, b equals 3. Now we have our y-intercepts and the slope. So now we could do what? That's right, we could write the equation. Last step here is to write the equation. Now, in a few weeks, we won't have to do that because we'll use another form that will just transform into slope-intercept. There's no replacing things, right? So there's no solving or anything like that. We will have to just write the equation, transform it. All right, so we have y equals our slope, which was -3/2 of x. That was up here, first step. Okay, got our slope. And then times x. So what's our y-intercept? 3. So plus 3. So our equation is -3/2 of x plus 3. All right, for the last example, I am going to show you the long way to do these kind of problems. If all else fails, you can always do this. You can graph. Let me change that. You can graph to see both your slope on a graph. That'll be your rise over run. But also, if you extend the line through those 2 points, you'll not only see the slope, but you can also see the y-intercepts. You're going to see right where it crosses the y-axis. So again, this is the longer way. If you're given 2 points, you can graph to see both the slope, rise over run, and see where it crosses the y-axis for your y-intercept. We're going to do example 3, the same 2 points in example 3, but we're going to graph them instead. All right, there's the same example like I said. We're going to find the equation of the line through 3, -11, and 5, -15, but we're doing the long way this time by graphing to see the slope and y-intercept. So first thing first, we're going to plot the points. So step 1, plot the given points. Those are 3, -11, so 3, -11, and 5, -15. Let me go ahead and put those on here. All right, so there's a better graph we can now use. So let me plot those points, like I said. So 3, -11, 3, -11 should be right about here. And the next point we were given was 5, -15. So 5, -15 will be right about there, it looks like. All right, now we have our 2 points. Let's go ahead and draw a straight line through those points. All right, now we have our line of our 2 points graphed. Now we're going to find our slope by looking at our rise over run. So the next step is find slope. So we're looking for the rise over run. So let's find those 2 points. So at that leftmost point right here, we have to go down and over. So let's go ahead and count how far we have to go down. Looks like we can go 1, 2, 3, 4. down 4 and to the right 2. So our rise is -4. Our run is 2. That simplifies to the ratio of just -2 for our slope. Okay, so now we need our y-intercepts. So let's go ahead and see where it crosses. It crosses right there at -5. So that's our third step, was identify the y-intercepts, which we saw is 0, -5. Again, it's right where it crosses the y-axis. Once we have those two parts, we can now write the equation of this graph. So let's do that right down here for the last part. Equation. So again, we're replacing M and B with what we just found on the graph. So y equals our slope, -2 times x. And then our intercept we saw is -5. It's the exact same answer we got on example 3, but a longer way. If you don't know how to work back on a table to the y-intercepts, or if you're not sure how to solve for the y-intercept yet, you can do the long way, and that's graph and find your slope and your y-intercepts. All right, may the math be with you.